Alrighty, I'm here to discuss problem set 3.6 with you guys. I'm going to do a lot of this on Desmos, so we're going to graph y equals 2x minus 3. Looking at number 1 here, so here's what 2x minus 3 looks like. To do this by hand, remember you'd start with a y-intercept of -3. So 0, -3, which is right there. Then you go up 2 over 1 to get that next point. Oops, not that point, but it would be this point right here, right there, which I can't, somewhere right around there, to get another point, and then you can just draw a line between those 2 points. Number 2 says, now graph the linear inequality, y is less than or equal to this. And we get that. And it says by shading below this line. So we're going to shade below the line because it says y is less than or equal to. So since it's less than, we're going to shade below this line, which is, you can see in Desmos, it does that for you. Now plot the point -3, -6. And, oops. There we go. So there's the point -3 and -6, and it says, does that make the equation true? Now, graphically speaking, since it's not on the line, it's close to it, but it's not actually on it, then it's not a solution to the equation. To be a solution to the inequality, it would have to be in the shaded region. Every single point that's in the red shaded region is a solution to the inequality. So since this is not in the shaded region, it's not a solution to the inequality. Since it's not on the line, it's not a solution to the equation. Okay? So now we can jump to number 4. We're going to graph 2 different inequalities here. So this is a system of inequalities now. Both inequalities need to be true at the same time, just as they were with systems of equations. And we have y is less than or equal to 3. Oops, y is less than or equal to. Oops. Y is less than or equal to 3x plus 4. Okay, let me change this color if I can. All right, that looks better. Okay, so now it says what part of the graph represents y is greater than -x plus 2, and that is the shaded green region. I'm going to zoom out so you guys can see more of that. And then the shaded blue region is the part of the graph that represents y is less than or equal to 3x plus 4. And it says, so 5 says in the graph of these inequalities, y is the first line dashed and the second line solid. That is because of when it's greater than or less than, then it's a dashed line, because points on the line are not solutions. If it's less than or equal to or greater than or equal to, then it's a solid line like we see on the blue line, and that is because points on the line are solutions. Okay, so now we're going to consider the point 0, 0. I'm going to just plot that over here. Okay, there it is. And it says, does 0, 0 lie in the shaded region of y is greater than -x plus 2, which is the green? And no, it does not lie in the green. And then if we substitute 0, 0 for x and y over here, we get 0 is greater than -0 plus 2, which would get us 0 is greater than 2, which is false. So algebraically, you can see that it's not a solution, which is why it does not lie in the green region, because 0 is not greater than 2. And then C, does 0, 0 lie in the shaded region of the other line, which is the blue? And yes, it does. You can see it right there. And then we're going to substitute again and get 0 is less than or equal to 3 times 0 plus 4, which is 0 is less than or equal to 4, which is true. And so that is why that point will end up being in the shaded region for the blue line. Okay, we already did this. Part E, now enter the point 0, 0 on Desmos. Check the label box. Is 0, 0 a solution to the system of inequalities? And no, it is not, because it's only in the blue shaded region, not the green shaded region. Also, algebraically, we showed that it doesn't work here, but it does work here. But to be a solution to a system, it's got to work for both. Okay, so now we're going to start with another point using these same inequalities, 4, -1. Okay, and now we can see that 4, -1 is in the shaded region for both, where the shading overlaps. So the answer to 7A is yes, which is the green part. And then it is in the shaded region for the blue part as well. And then we already entered it on Desmos, so we already did C. Is 4, -1 a solution to the system of inequalities? Yes, because it's a solution to both inequalities. Yes, it's a solution to both inequalities. Which is to say, it's in both shaded regions. It's in both shaded regions. Okay. Name another point that is a solution to the system. So any point in this like aqua color section here. So like, I'll label one, but like we could do 20, 0, for example. I'm only saying that because it's just one that I see. 20, 0. So see that green dot that just appeared? That is in the shaded region for both. So there's infinitely many solutions. It's every single point that's in this shaded region, which, you know, there's so many of them. Infinitely many. All right. Okay, so we already did F and G. Jumping down to number 8, consider the system. All right, so we have a new one. So let's graph this. Y is greater than or equal to x minus 1. And y is less than -2x plus 5. I'm going to change that color again. Let's go to orange. All right. So now it says graph the boundary lines of the system on the grid to the right. Use dash or solid lines as appropriate. So I've already graphed this on Desmos just to make it faster. But this line, which is our purple one, is going to be a solid line because it's or equal to. The orange line will be dashed because it's just less than, not or equal to. Okay, so I'll color code these for what we have in Desmos over there. Shade the side of each line that shows all of the solutions to each inequality. So since this is greater than, the purple area is shaded above the purple line. Since this one's less than, we've shaded below the orange line over here. Okay, so you can see where the orange shading is below the line and the purple shading is above the purple line. Plot 2 points that are in the solution set of this inequality. Write the coordinates of your points below. So pick anything that's in the darker orange area, which is where the orange and purple are both having it at the same time. So I'm going to pick like -2, 0, and I'm going to show you that it does in fact work. There it is. And we can do like -8, 5, it looks like, is one. Let's see. So -8, 5. There we go. So again, I'm just looking for points that are in the shaded region for both. Okay. So I'm going to put those on here. -2, 0. And we did -8, 5. Okay, and then graph on Desmos to check your answer, which we already did. Number 9, graph the system. So we have another system here. Now you should be graphing these by hand and then checking with Desmos, but it's just about graphing lines using your slope and y-intercept. So I think you guys can probably do that. Okay. And we have y is greater than -6x minus 4. If you're struggling graphing lines, then you got to make sure you ask me questions about that, because if you can't graph these lines, you can't get these problems right. Okay, change the inequality symbols to write a new system that has -4, 2 as a solution. So let's see the point -4, 2 right there is not a solution to the system. In fact, it's not a solution to either one. So if we change both of these, make this one less than, now it's in the purple. Make this one greater than or equal to. Now it's in the green as well, and it's in the green and purple. All right, and then use substitution means plug the point -4 and 2 back into both of these. So plug in -4 for y and 2 for x into this one, and show that you get a true inequality. But you can see graphically on Desmos that it does work. Number 10, fill in the missing numbers and symbols in the inequality so that 6, -3 is the solution to the system. Then check your answer in Desmos. So there's going to be all sorts of things you can do here. So we have y is greater than, let's just say negative 5x so what we need here, negative 3 for y has to be greater than something times x and then plus or minus 1. So if we make x like negative 5, so we make this negative 5x and then plus or minus 1, it doesn't matter. That's going to give me negative 3 is greater than negative 5 times 6 plus 1, which is negative 3 is greater than negative 29, which is true. So the first one I came up with is y is greater than negative 5x plus 1, and then I'm going to plot my point, 6, negative 3, and show that it is in fact in the red over there, which means it is a solution to that. And we also need it to be a solution to this next system. So if you want to, we can just like mess with stuff over here. Let's say it's y is less than, let's go with 2x. And look, that works right there. So we could say plus 0, really plus any number at this point, because that's just going to move the green graph up, if you remember. So there we go. So we could say y is less than 2x plus 5. Oh, wait, sorry, it was supposed to be negative 7x to begin with. Hold on. Sorry about that. I was thinking we were picking that number. Negative 7x and then we got to make this plus a pretty big number here. Let's make it like plus 50. And there you go. It's in there now. So that one's kind of weird. So we can say y is less than negative 7x plus 50. Okay. Number 11, the solution to a system of linear inequalities includes the point 5, negative 1. One of the inequalities is y is less than 2x minus 9. So let's look at y is less than 2x minus 9. We know that's going to be one of the inequalities. We know the point 5, negative 1 is a solution. And it's in the purple, so that's good. Write another possible inequality in this system. So I'm going to make one that has a negative slope so that it goes downhill from left to right. So let's say, and I'm going to make it less than that line also. Y is less than, let's say, like negative 2x. And then if I just shift that up, like, I don't know how far, let's say plus 10. Oh, plus 10 looks like it works. Let's make it even more obvious, like plus 20. Now you can see for sure that that 0.5, negative 1, which I just labeled there, is in the shaded region for both. And then B says, is this the only inequality that can be used to form this system? No, there's infinitely many. Let's just keep doing a number bigger than 20, like 30. That's just going to make this keep getting plus 50. It's just going to make that red region bigger and bigger, but always include that point. Okay, now clear everything from Desmos and start over. Graph this system. Y is less than x plus 3. And y is greater than or equal to x plus 5. Okay, let's hit the home button there to get our zooming right. And consider the point 0, 0, which you can see, but I'm going to graph it anyways. All right, there it is. Wait, y is less than x plus 3. Y is greater than or equal to x plus 5. All right. Use substitution to check to see if 0, 0 is the solution to the system. Show your work. So plug 0, 0 into this and 0, 0 into that and see what you get. But graphically, you can see it's going to work for the blue one and not for the green one because the point lies in the blue section, but not the green shaded region. Now consider the point 1, 5. So let's get rid of that one. We'll do 1, 5. And use substitution to check to see if 1, 5 is a solution to the system. So now you can see graphically that that point is not in either shaded region. So it's not a solution to this or a solution to that. Therefore, it's for sure not a solution to the system because it doesn't even work on either one. But to be a solution to the system, it's got to work for both. All right. 13, suppose you change the inequality symbol for the first equation, I should say for the first inequality, to form the system y is greater than x plus 3. And y is greater than or equal to x plus 5. Do you think this system has a solution? Why or why not? Well, yeah, it has a solution. Not the point that's on there. The 0.15 is still not a solution because it's only in the blue. It's not above the green line. But everywhere where that dark shaded region is a solution to the system. So like, I'll put a point on there. Let's say it's going to be like 0. This is just an example. 0, like 20, it looks like. Yeah, right there. So that's a solution. Another one would be like -5. And it looks like maybe even I could just put 2 maybe. Yep, there we go. Or I could do -5. And you can see any point that's in that region. Okay? And so that is what it means to be a solution to a system of inequalities.